Okay, so last example in this section for your quiz. So, example 8. We're going to list 4 non-zero terms of the Maclaurin polynomial. What do you think of when we think of Maclaurin polynomial? Center is 0. For f of x equals sine of x, f of x equals cosine of x, and f of x equals e to the x. Find the following Maclaurin polynomials. So they want us to only go to 4 non-zero terms. So let's think of just sine x first. Okay, we want to find the Maclaurin polynomial, first non-zero terms, first 4 non-zero terms of sine x. Well, sine x, haven't we already done some work with sine x previously in this section? So, if we're not looking to redo the entire work we've already done, don't reinvent the wheel, go back in your notes and try to find sine x and see if we have found the first 4 non-zero terms. Now remember, eventually, this is one of the ones I had you write on a note card if you have a note card, that eventually you should try to remember because it has a pattern to it. But what is it? When you find it, let me know.
Is it just going to be x minus x cubed over 3 factorial?
That's 2 non-zero terms.
Is it beginning with 5 things with 2?
Okay, that would be 3 non-zero terms. I need 4 non-zero terms. If you follow the pattern, what would my next term be?
Minus x to the 7th over 7 factorial.
Okay, so that's the first 4 non-zero terms of sine x. Again, with that pattern, you could continue to find more. So another way to remember this one, if you look, what are the powers of the exponents? Odd. The sine of x is an odd function. Okay. So are we okay? We derived that before. Are we okay where sine x came from, finding it using the Maclaurin polynomial? Okay, another one is cosine x. Now, we didn't actually find this one yet, but think about what we're doing. We have sine x. How do you think we can find cosine x without going through the entire process of using the Maclaurin polynomial and plugging in for cosine of x? Okay, well this is going to be an even function. You are correct saying that. If I cover this part up and you just think about sine x and cosine x for a minute, how can you get from sine x to cosine x? Take the derivative. Well, how can we get from a sine x Taylor polynomial Maclaurin to cosine x Maclaurin polynomial? Take the derivative. What's the derivative of x? 1. And then we have, remember, all these factorials on the bottom, those are constants, so we need to just take the derivative of our x values. The derivative of x cubed. I'm going to write a long drawn out version and then we'll simplify it at the end. So what would be the derivative of x cubed? 3x squared. So we're going to write out the long version, then we'll simplify when we're done. Then I need to take the derivative of this one, so 5x to the 4th over 5 factorial. And then 7x to the 6th over 7 factorial. Are we okay so far? Just took the derivative of our x values. Now if we actually simplify this, well, 1 remains 1. How can I simplify the 3x squared with a 3 factorial? Yeah, 3 factorial is the same as writing 3 times 2 factorial. So our 3 on the top will cancel with a 3 on the bottom and we'd be left with 3 factorial. So x squared over 2 factorial. What's the next one going to be? X to the 4th over 4 factorial minus x to the 6th over 6 factorial. again, we see cosine has a pattern, but it's the even function, like Eric had mentioned. So if you remember sine x, like I told you should have it memorized, you'll be able to get cosine x from it. And if you remember sine x and cosine x, they're very similar. If you know even and odd, probably both of them will come pretty easy to you. But as long as you remember sine x, you'll be able to figure out what cosine x is. So this one is actually the 4 non-zero terms for cosine of x. Okay, so we have sine x, we have cosine of x. Are we okay with how we derived and simplified all that? All right, last one they want us to find is the approximation of e to the x. Well, I think we found that one too. What was the first 4 non-zero terms of e to the x? And again, this is another one eventually you should try to memorize.
1 plus x plus 1 half x squared plus 1/6 x.
It's 1 plus x squared over 2 factorial. 2 times 1, yeah, just 2. Plus x cubed over 3 factorial. So just keeping the pattern. So you multiplied out the factorials. I'm just leaving it as the factorials because that's what the pattern is. That way you can recognize it. And when you think about these problems, they're all having factorials on the bottom. So yeah, you can simplify it and multiply them out, but the pattern might be harder for you to recognize because the pattern is with the factorials. So that's the first 4 non-zero terms of e to the x. Now the reason we found these is because we're going to use these, the base ones, the ones that we are supposed to have at least in our memory bank somewhere or can try to quickly remember, and we're going to use these to find the approximation of the 3 at the bottom. So we're going to start with g of x. G of x is equal to sine of 2x. So we want to approximate sine of 2x. So how do you think we're going to use our original one to approximate sine of 2x? Exactly. Everywhere there's an x, we're going to plug in a 2x. So again, if you have the general formula in your head, you're going to just take the x and replace it with 2x everywhere. And this would be the approximation of sine of 2x. Again, if you would graph that on the calculator, you're going to get an approximation that's very close to sine of 2x. And you could follow the pattern and expand it on further and eventually get a very, very, very close approximation. So do we kind of understand now, looking at this example, how we're going to modify the simple ones we found to maybe find an approximation of a more complex problem? Any questions about A? Alright, let's go ahead and try B. So this is for A. Let's try B. G of x is equal to x cosine of x. So we could go straight to a simplified version, or if you don't want to do that, we could think of what we should do first. But Eric, you had your hand raised. What were you going to say? Yeah, so we can skip that intermediate step of just writing out and showing everything in parentheses multiplied by x, and we can just multiply it all by x. So take the cosine, and you're going to multiply each term by another x. So it would be x cosine of x is approximately x minus x cubed over 2 factorial So again, the x this time wasn't inside the cosine. It's multiplying whatever the approximation for cosine of x was, just multiplying another x to everything. So exactly what Eric had said. We're just multiplying everything, that entire original approximation, by x. So again, another way to think about that is if you would have put parentheses around everything and just wrote times x. Are we okay with example B? All right, let's go on to C then. I'm going to, can I erase the first two? Everybody have those down? All right. So C, we have 4e to the x and x is squared. So we want an approximation for that. Well, we know what the original is. So let's kind of do this one in 2 steps. That way we don't get confused. Let's think first about the e to the x to the squared. So what is that going to change about the original one? Again, look up here. We have the approximation of e to the x. So what's going to change? Every x is going to have a square. So I'm going to leave just a little bit of room there because I'm not done yet. 1 plus, everywhere there's an x, it's going to be an x squared now. Okay. So that was just making sure every x had a square. What else do I need to make sure I do? I have to multiply everything by 4. So then you can go ahead and write your simplified version. Everything multiplied by 4 and every x has the x squared. If you want to, you can simplify with your factorials. So again, it's going to be 4 over 2 factorials, so that was just going to change to 2. X squared times x, or x squared squared is x to the what? 4th. And then I have 4 over 3 factorial, so 3 times 2, so 6. 4 over 6. 2/3 x to the 6th. So now I used the approximation for e to the x that I knew from before, and I was able to approximate this new equation for e to the x squared. So now if you would type this in your calculator, obviously you're going to get a very close approximation to that e to the x function. So again, everything we've done so far has taken some function that may be hard to wrap our heads around, like sine or cosine, and put a polynomial that will help approximate it, which is a lot closer approximation than using the lines like we have before. Yes?
I have a question. Since 4 times e to the x squared, would that be equal to 4 e to the x times e to the x? I mean, just even if you ignore the 4, is e to the x squared, is that equal to e to the x times e to the x? Or would it be e to the x?
E to the x times e to the x. If you have e to the x times e to the x, what do you do with the exponents? Add them, so you would have e to the 2x. So it is not the same thing. Does that answer your question then? Okay. Alright, so like I said, that finished example 8. We finished this section. If you want any note cards to write down anything that we've learned so far, any of these that you may have not written down, you use any time to work on homework, maybe study flashcards with a partner, section 3.1, 3.2, and 3.3, that quiz will be on Monday. So you have today and tomorrow to study or do some homework to study for that quiz, okay? Alright, so try to make the best of your time. You have the rest of today also.